Hello dudes. Today, we will be talking about Uranus. Enveloping a diameter of over 30 inches, Uranus is the third biggest planet, with a whopping size of approximately 50,000 kilometers. Now, we all know the reputation this planet has, and we're all mature adults. Right. Anyways, what we're most interested in is what makes Uranus unique from others. Apart from the other planets, Uranus is the only one to tilt on its side, possibly because another planet banged or collided with it. Along the tangent of having a planet collide with Uranus, that could explain why Uranus is the coldest planet in the solar system. The theoretical planet that collided with Uranus not only tilted it sideways, but also depleted the potential energy held within the planet. Now, when was this planet discovered? Well, some dude named William Herschel was looking through his telescope when he saw Uranus in the sky. At first, he thought it was a comet or a star, but it was confirmed a couple of years later to be its own planet. After it was confirmed to be a planet, William Herschel wanted the pleasure of naming it. You'll never guess what he wanted to call it. Georgium Sidus. Yep. Just Georgium Sidus. Imagine hearing about the planets in science class, and the seventh planet was called King George. Well, unfortunately, that name didn't stick, and Johann Bode suggested a name derived from the Greek god Uranus. And thus, the planet got its name Uranus. Let's go back further into its history, to the very creation of Uranus itself. Around 4.5 billion years ago, somewhere around the age of our own planet, but a little younger, a swirl of gas whirled together into a gas giant, a planet composed almost entirely out of an atmosphere, kind of like a giant storm in space, and that was how Uranus formed from a cloud of gas. Now, let's move on to what we've been meaning to talk about, what's inside Uranus. To start, let's understand its atmosphere. Uranus gas is composed primarily of hydrogen and helium. That means if you were falling inside it, you would let out a high-pitched screech on your dying breath. Along with hydrogen and helium, Uranus also has trace amounts of ammonia, water, and methane, with the latter being responsible for its light blue color. The winds of Uranus blow at about 900 kilometers per hour, or for you fellow Americans out there, 560 miles per hour. For reference, the fastest wind speeds ever recorded on Earth were produced by Hurricane Olivia, and it reached a top wind speed of 408 kilometers per hour, or 254 miles per hour. That means the wind speeds of Uranus reach 221% higher than the fastest wind speeds of Earth. To top it off, a Uranian day is 17 hours compared to Earth's 24 hours, which makes it a mildly uncomfortable fact to know that despite Uranus being larger than Earth, it rotates quite a bit faster. This is all very dreadful, isn't it? Well, why not experience it firsthand? Let's see what would happen if we entered Uranus and figure out how much your spacesuit and body can handle. As soon as we penetrate Uranus, things would start to get wet. The same would be true for all the gas giants, as falling through clouds would soak you in the clouds' moisture. Not only would you be soaking wet, but you'd also feel colder than you would stepping out of a pool without a warm towel. Well, now I guess we know why the Hitchhiker's Guide to the Galaxy recommends that you bring a towel through interstellar space. Anyways, as you fall in, the winds break way to a weird slushy sea of water, ice, and ammonia crystals. Think of it as water lava. Despite being a liquid, this pressurized mix of water, ammonia, and methane can remain a liquid and can climb up to thousands of degrees Fahrenheit or Celsius. It gets crazy on both scales. As we go deeper into Uranus, the temperatures climb to a scorching 4,982 C, or over 9,000 Fahrenheit. The pressures as well can be overwhelming at the core. Uranus can crush things with the force of 7 million atmospheres, or over 100 million pounds per square inch. Following the math, Uranus has a crushing force stronger than the weight of a dump truck per square inch.
That's some respectable power right there.
Assuming that we're still alive, and that we've successfully survived through the respectable power of Uranus, we've officially reached the core of the planet. the core of Uranus is expected to be a collection of dense hot metals. What now? Well, we haven't thought much about the return trip, but we'll try to save you in whatever ways we can. Oh. One last thing worth mentioning is that despite the fact that Uranus is often called a gas giant, it's really more of an ice giant, with its mantle composing more of the planet than its atmosphere. With that being said, we've finished our journey. Now that we explored Uranus, you can now develop a stronger, more thorough understanding of what makes this planet a little more interesting than a casual joke. It's still kinda funny though.